Hey there, creature. Are you ready for me to show you my magic trick? Sure, but why are we in a graveyard? Because it's Halloween, silly! That just makes it worse! Anyway, let's see here. Marchuus idiotum vivica! It's alive! It's alive!
Letters! It looks like you're writing letters! Letters!
Did you just raise Clippet's grave? I thought most people wanted him to stay dead. About that, I should have checked the headstone first. Well, you're kind of a moron then. Just kidding, you're great, Carl. But this was still a terrible idea.
It looks like you just raised the dead. Welcome to the zombie programming language.
Zombie is an acronym standing for Zombie-Oriented Machine Being Interface Engine. Let's get this out of the way. If you think this is a recursive acronym, you are wrong, since the language's name is in uppercase, but the word zombie here is in lowercase. And case sensitivity matters in my mind. Zombie was designed by David Morgan Marr, aka Danger Mouse. He is also well known for designing Pete, a language designed for abstract artists. Zombie was designed for necromancers, and I quote, particularly evil ones. Thanks for the clarification. Actually, when you think about it, necromancy isn't completely evil. I mean, you're giving this dead corpse the gift of life back. For this language, I made my own interpreter. It has some differences with the actual zombie specification, since the specification contains some things that don't make any sense, but in general I kept everything as similar to the specification as I could. In zombie, you control, well, zombies. To declare a new zombie, you type zombie name is a zombie, followed by a summon animate block structure. Inside the summon animate block is where the zombie's instructions go, and zombies perform their tasks from top to bottom. A task is a structure containing commands that the zombie does. Anything that happens during the task goes between task, task name, and animate. Inside of tasks, instructions can be run, such as say, which prints a message to the console. This simple program will print a shopping list to the screen, and this will be done by the zombie named Clippet using 3 separate tasks. Anyway, zombies are not the only type of entities that can be summoned in Zombie. You can also summon ghosts, vampires, demons, and... oh dear, what is this consonant question? Okay, this seems to be describing genies, so I'm just gonna take the easy route and call them genies, instead of djinns. Entities all run at the same time, making Zombie multi-threaded for some bizarre reason. Zombies are entities that run your code in the exact way you write it, like, you know, you would expect from a programming language. Ghosts are very similar to zombies in the code itself, except for the fact that they are disturbed instead of animated. Ghosts run their tasks normally, but they have one little quirk that I think would be explained best by demonstration. That's right, ghosts take a random amount of time to perform their tasks, because they just don't like you. Vampires perform their tasks in a random order each time, so your shopping list gets shuffled each time you run the program. Also, vampires are free-willed, which means that their summoning ends with bind. Using bind to end a summoning of a ghost or a zombie will cause them to start off inactive, meaning they won't run their code unless they are told to by another entity. Free-willed entities, which includes demons and genies as well, will start running automatically at the beginning of the program, whether you want them to or not. Genies, or djinns, may perform their tasks, or they may not. Or they may perform the task several times, or in the wrong order. It depends on what the genie really wants to do that day. Also, the specification says that genies and demons may perform multiple tasks at once. So I guess multi-threadception is a thing now! And my interpreter does not have this because I didn't think it was all that important. Anyway, as for demons, they do, well, this. So, demons will run everything in a random order, but summon more demons to, quote-unquote, help it. The specification states that this may or may not be a good thing. But speaking from these results, there's not very many times when it would be a good thing.
So, based on these entity types, why would anyone want to use an entity other than a zombie? I mean, they're the only ones that run things 100% based on what you say.
Well, Mr. Dinosaur Creature Guy, you'll find out the uses for those entities soon. Anyway, now let's write a program, as opposed to sitting around with this language not writing a program. Our program will output the lyrics to the song 99 Bottles of Beer on the Wall. This program contains 2 zombies. The first one remembers the value of 99. Each entity can store 1 integer. The zombie Bottles will store the amount of bottles currently on the wall, and he is bound instead of animated because he has no tasks. Clip It is the zombie that performs the actual printing of the lyrics. The lyrics go in a shamble until loop, which is basically the equivalent of a Java do-while loop, except because evil, it keeps running while the condition is false instead of true. The until statement means that it will loop the code between it and shamble until the condition is met. In this case, the condition is remembering bottles 2. Yeah, I know the grammar police felt like taking the day off here. It would make more sense to say bottles remembering 2, but still, it will stop shambling once bottles is remembering the value of 2. Inside of this loop, we want to print the lyrics. To print an entity's value, you say moan followed by the entity's name. Moan basically retrieves the entity's value so we can use it now. Anyway, the printing of the lyrics is pretty straightforward until we get to the subtracting part. We need to subtract 1. To help with this, Clip It starts off remembering -1. To add 2 numbers together, you use a line like this. And yes, I know, it looks like a complete and total mess. This line will cause Bottles to remember the sum of the following values. In this case, he will remember the sum of Clip It and Bottles. And since Clip It now holds the value of -1, a bottle will be removed from this total. The loop cuts off at 2 bottles of beer. After that point, it will simply print the remainder of the lyrics, but without the grammatical issues that occur when saying 1 bottles of beer.
Yeah, that's great and all, but where's the pizzazz? 99 is such an overused number. How about generating a random number to use? That'll be interesting.
The new version of this program starts with bottles being 1. Since in Zombie, all entities run at once, and we don't want the song to be printed until a number is actually generated, Clip It will be turned into a ghost, which will delay the printing, hopefully at least most of the time. To generate the random number, a daemon is used. This daemon has 3 tasks which add 1, 2, and 4 to bottles. This daemon would of course clone itself a random number of times and give us even more bottles. The end result should be a random number, and that number is used in the regular old boring 99 bottles of beer program. Now let's do a truth machine program. Pause if you don't know what that is to read the description now. Now, the description of the truth machine clearly states that it requires the user to input something. Well, guess what? Zombie doesn't include that feature. Luckily though, we can summon a genie to generate the number for us. This genie starts off remembering 0, but it has a chance of running this task here and remembering 1. But this gives 1 a slight advantage, so there's yet another task that remembers 0. Anyway, after this genie figures out which number it wants to use, a ghost Clip It evaluates it. Clip It will say the genie's value once and keep doing it until the genie is remembering 0. If it starts out remembering 0, it doesn't repeat at all, and if it starts remembering 1, it gets stuck here.
There will be no escape.
Anyway, let's run this slightly unpredictable truth machine that, like the 99 Bottles of Beer program, forces you to wait a random amount of time for the ghost to start. Remember those viral math problems that were a thing a year or 2 ago? They're pretty dumb. I mean, order of operations states that you add 1 and 2 together, divide 6 by 2, and multiply the result of that by 3. The answer is 9, and Google verifies that this is correct. Anyway, let's see if a vampire who executes tasks in a random order can solve it correctly. The top of this program will set all the variables needed, as well as a temporary variable that gets used when multiplying. The vampire itself has 4 tasks. The first task adds the variables holding the values in the parentheses together and prints that it ran the first task. In fact, all of the tasks see that they've ran themselves. The second task divides the first value by the second value and stores it into the second value's variable. Division is accomplished using rend, which divides the 2 terms following it. Preceding it. Zombie reads these things backwards. The third task multiplies the second term by the third term, and this is quite possibly the most involved one. It takes var2 and stores its value into a temporary variable. It then subtracts 1 from var3 and adds the temporary variable back into var2, and then it repeats this until var3 contains the value of 1. var2 at that point should contain the result. The fourth task is thankfully much simpler and prints the second term's value, which, if this is done correctly, should contain our answer, and banishes the entity to the underworld for all eternity! Which basically means stopping its thread. Now let's see how many tries it takes until our vampire friend can solve this math problem correctly. Okay then, 8 tries! Now let's put it up against a brainless stupid zombie. One try!
You failed, vampire! Don't be mean to it, it might suck your blood, but I'm the necromancer here, and I banish thee, creature! Ha! Your necromancy powers have no effect on lizard monsters like me.
Anyway, my zombie interpreter and programs are in the description. Also, I have included the Java source file so that you can edit the interpreter, and so you can fix an annoying bug that I probably left in and didn't notice. Anyway, thanks for watching, and I'll see you in the next one.